Now let's take a few moments to discuss what T2 lesions are, where they are, what they look like, and how we quantify them. So T2 lesions, as we mentioned before, are really the hallmark of MS pathology. They're not the only pathology, but they're the most salient and the clearest and most obvious thing that you'll see on imaging in general. So I want to point out that we don't have time in this brief tutorial series to really go into all the intricacies of the pathology, what these lesions represent, all the details of every false positive, false negative, types, diversity. And so you should certainly take some time to look at some of the additional resources, in particular the Atlas of Lesions in MS that is part of SOP D1000 at the BNAC is an incredibly valuable resource, and you should certainly take some time to look through it. But very briefly, what are T2 lesions? So they are alterations in the T2 property of the tissue. And this is a little bit of a esoteric concept. It may not be obvious to you what T2 means, and it really has to do with just the interchange of energy from different spins, and it doesn't really matter other than to say that it's a measurable property that all tissues have, and that as the tissue becomes has a higher water content, you tend to see increased T2 times. So they take longer to dephase. And so what we're seeing on these images is generally fluid shift contents, although many other biological properties can also alter the T2 properties. Usually what we're looking for is that lengthening, though, that's going to be associated with this brightness on a flare image, or on a T2 weighted image. And the kind of things that are going to contribute to these T2 lesions are extremely varied. They can be inflammation, demyelination, gliosis, edema, axonal loss. All these different things will show up as a bright T2 lesion on flare. And so that's both simultaneously the great advantage of T2 lesion quantification and T2 lesion assessment in general, and also its Achilles heel. It is incredibly sensitive to all kinds of pathology, and so we will see as a lesion most things that involve any kind of focal alterations. But at the same time, it is very nonspecific. It represents a spectrum of pathologies that can have a dramatically different impact on clinical and patient outcomes. Obviously, mild edema is substantially different than complete loss of axons in an area. So, where are these lesions? So in MS, these lesions can really be anywhere in the central nervous system. They do have a predominance periventricularly. So we'll see a lot of periventricular lesions in MS. But it's important to note that they can also be infratentorial. We can see lesions down in the cerebellum and brainstem areas, as we see here, for example. And they can also be near the cortex. We can see juxtacortical lesions. We can see lesions further away from those periventricular areas. We have some examples here in this case, here in this case. So they can vary throughout the brain and spinal cord, and we need to be on the lookout for them everywhere. What about their size and morphology? As varied as the pathology is, as varied as their location, it goes the same for their morphology. These lesions can have a broad spectrum of different shapes and sizes. In general, most of the lesions are usually small. They're going to generally be round or oval. They can also follow along veins, as in Dawson's fingers, that can kind of radiate away from the ventricles, but that's often best seen in a sagittal view, and you won't see it as much if you're working in an axial view. In many cases, though, as MS proceeds, the lesions can become confluent. They can begin to have more diffuse edges and can start to run into each other, so that you'll see large complexes of lesions instead of a single lesion. Another important aspect is that the dirty appearing white matter, areas that are kind of intermediate between full-blown lesion and slightly abnormal tissue can show up. You can see these areas where there may be a little bit of brightness on the image, but not clear lesion. And the line between dirty appearing white matter and lesion is not generally well defined. So that can be a challenge as well.
Just as an aside, it may also be referred to as diffusely abnormal white matter.
Yeah, very good point. Yeah, so you'll hear it referred to as different things. And it'll be a bit of a challenge. And the way we deal with that is to also use semi-automated approaches and to try to rely for the delineation on some automated tools. So that actually brings us nicely to the next topic we want to discuss, which is how do we quantify these lesions? So, as you saw in the sample case, the basic process is straightforward. We use a process called ROIs, or regions of interest, and we use that GIM toolkit to essentially just delineate these areas of hyperintensity. So I'm just going to zoom in on one so we can see. And so we just go through and make these ROIs throughout the image. And it's important to remember that we're working three-dimensionally. So you're looking at two-dimensional slices of a three-dimensional object. So as we move through, it's important to think about connectivity and continuity. And as we quantify the images, these ROIs will be kind of stacked and put together as the slices are, and analyzed as three-dimensional objects. So what we're going to be doing on a day-to-day basis for this kind of T2 lesion analysis is actually fairly straightforward. We're basically looking for abnormal bright things on T2 flare-weighted images like this. And specifically, we're looking for abnormal T2 lesions, which almost will always also be bright on flare. They may occasionally become dark when there's extensive pathology that makes the tissue look like CSF. We'll discuss that later. But in general, we're looking for these bright areas on flare. And trying to just distinguish between some false positives, false negatives, true positives, and true negatives. And so most of the challenge is going to be finding, beyond the obvious lesions like this one, understanding which things that are bright that we shouldn't outline and which things are dark that we should outline. So, not everything bright is abnormal. The choroid, plexus, vessels, some artifacts can sometimes be bright and aren't lesions. Not everything dark is normal, as we just mentioned before. Some of those, in cases of extreme tissue damage, it can become dark on the flare. And the basic idea will be we want to just proceed through every slice one at a time and do these ROIs. And we'll move back and forth as we go along to get a clear picture of the anatomy. Usually you want to go a couple times up and down through the image. We may want to look at the ortho views, look at different intensities, but that's the general process. And you'll gain experience as you move through looking at different cases. So what we're going to do now in the next session, we're going to spend some time basically discussing some of those false positive and false negative areas, because I think you'll probably not have much problem finding these obvious bright areas. You will have to learn how to distinguish, though, all those different things that are sort of special cases. And so we'll go through and deal with each of those in turn.
That was good, other than the breakup in my connection for a second.
That's fine.